All right, proving that a quadrilateral is a parallelogram. First, to review the 5 different ways, or 5 different properties that we know about parallelograms, which are the ways to prove that a quadrilateral is a parallelogram. So the first is by definition. We can show that opposite sides are parallel. So if that side, one side is parallel to its opposite, and the other is parallel to its opposite, so we have 2 sets of parallel sides, then our quadrilateral is a parallelogram. We also have parallelogram opposite sides converse. We show that both pairs of opposite sides are congruent. So for instance, those two, okay, opposite sides congruent. We have the parallelogram opposite angles converse, showing that opposite angles are congruent. And then we have the parallelogram's diagonals converse, showing that diagonals bisect each other. So in a parallelogram, diagonals always bisect each other. Meaning that their point of intersection is the midpoint of those diagonals. Just might be a quick note for us. Okay, and then opposite sides, parallel and congruent theorem shows that one pair of opposite sides are both parallel and congruent. It has to be the same set of sides that are parallel and congruent. Okay, so using those, what we can do is we can use those properties to start identifying parallelograms and to actually find lengths and angle measures of parallelograms. So in quadrilateral ABCD, okay, so first I'm going to go ahead and label it ABCD. Measure of angle A is 48 degrees. Measure of angle B is 132. Measure of angle C is 48. Find the measure of angle D. Well, there's a common mistake that's made on a problem like this. First, we cannot assume it's a parallelogram. We have to go with what we know, and we know it's a quadrilateral. And what we know about a quadrilateral is the sum of all angles, the sum of the interior angles, is 360 degrees. So if I add up all of my interior angles, oops, excuse me there, 132 plus 48 plus 48 plus the measure of angle D, that has to equal 360 degrees. And so we know that the measure of angle D plus, well, those 48s and that 132 combined, it gives us 228 equals 360. And subtract that 228 from both sides, we get the measure of angle D equal to 132 degrees. So this is 132. Okay? Now, some of you may have got that and said, well, I got 132, but I just said opposite sides of a parallelogram are congruent, or opposite angles are congruent. Well, that's true. However, we don't know that it's a parallelogram. So the reason it's 132 degrees is the sum of the angles of a quad is 360 degrees. So we know that measure of angle D is 132 degrees because some of the angles of a quadrilateral are 360. So is it a parallelogram? Well, yes, it is. Okay, it's a parallelogram because opposite sides, or opposite angles, excuse me, are congruent. So 2 different answers there, all right? Okay, let's go ahead and try another one here. If WXYZ is a parallelogram, what are the values of R and T? So this time they're saying if this is a parallelogram. So in other words, if this side's parallel to this, and this side's parallel to that, okay? Which doesn't help us with measures. However, parallelogram also means this side is congruent to this, and this one is congruent to that. So WX is congruent to ZY. And if WX is congruent to zy, then wx equals zy. And what that means is 3r plus 4, which is wx, is equal to 4x, or 4r minus 6. Okay, and that allows us to solve for r. So we get r minus 6 equals 4, so 1r is 10. And if 1r is 10, that means r plus 5, which equals t, okay, or wz equals xy, right? So we have r plus 5 is equal to t, and we know r is 10. That's 10 plus 5 is equal to t, or 15 equals t. All right. Okay, go ahead and find the value of r in this shape. First, we have to look at it and see what type of shape it is, and noticing that opposite sides are parallel, or one set of opposite sides are parallel, and that same set has congruent side lengths, or equal side lengths. Means we have an opposite side parallel and congruent, meaning that this is a parallelogram, which also means if I were to label this as ABCD, we would know that AB is equal to CD, which means 28 minus 4r will equal 2r plus 10. Okay, move that 4r over, we get 6r plus 10 equals 28, and then 6r equals 18, so 1r is 3. So r is 3, and you can make sure that that's accurate by plugging 3 in. 28 minus 12 is 16, and 2 times 3 is 6, plus 10 is 16. So that works out. All right, finding diagonal links in the parallelogram. What's the value of x? For what value of x makes this a parallelogram? Well, if this is a parallelogram, we have diagonals that bisect each other, meaning that 5x minus 7 would have to equal 2x plus 12. Or plus 2, excuse me. And that's because our diagonals bisect each other. To combine like terms, we'll move these two x's over, so we end up with 3x minus 7 equals 2. We'll add the 7 over, we get 3x equals 9. Divide by 3, x is 3. The value of x is 3. 5 times 3 is 15, minus 7 is 8, and 2 times 3 is 6, plus 2 is 8. So it works out. So one last piece, show that the quadrilateral is a parallelogram. Well, by doing that, in order for it to be a parallelogram, we have 5 different options, right? We can either deal with finding parallel sides, which means their slopes of parallel lines are the same. Okay, so for that and that, slopes would have to be the same. Or opposite sides are congruent, so you could think distance. The distance from, say, that point and that point okay, so the distance from A to B would have to be equal to the distance from C to D. Okay, so think distance formula. Opposite angles congruent, so we'd actually have to know angle measures. Diagonals bisect each other, so if you think of that, think of first to find the midpoint, you use the midpoint formula. Oops. And then you could use the distance formula. Okay, to find from vertice to midpoint. Okay, so you're kind of starting to see the different ways you can do this if you have some coordinates. So you have slope formula, for the top one here. You have distance formula for number 2. You have midpoint and distance for number 4. And then you would have to use slope formula to find parallel lines again. and then you'd have to use distance formula to find lengths of sides. So it's kind of up to you, and I look at this and I start going, well, distance formula is kind of cumbersome. It's a big, long formula. Slope formula is pretty easy to do, especially if you have a graph. And so what I'm going to do, I'm going to look at what they give me here. So notice I'm given coordinates A, B, C, D. I'm given actual, or the points, and then I'm given actual coordinates. I could easily use the distance formula, but it's a lot easier to just look at slope. So especially with a picture already made for me. So I'm just looking at rise and run. So from -1 all the way up to 10 has a rise of 11. And a run goes from -11 to -5. Okay? So the slope, so if I'm thinking of slopes, okay, well, the slope M of AD is equal to 11.6. And so let's go ahead and look at the slope of the line that appears to be parallel. All right, if I'm trying to classify it as or show that it's a parallelogram, let's make sure that these are parallel, have the same slope. So going from -3 up to 8, that is 11. And going from 3 to 9, that is 6. So the slope of C to B is also equal to 11.6, which same slope, so AD is parallel to CB. All right, now we have one set of parallel sides. Now I could either find the length of those sides, right, and the distance formula, and do opposite sides are parallel and congruent, or I could just find the slopes of the other two sides and find that they have two sets of parallel sides, which is what I'm going to do. Okay, so I know that. In fact, if I'm going to do that, let me go ahead and use the kind of stay color coordinated here, right? There we go. All right, and then go ahead and find the slope of A to B and the slope of D to C. Okay, the slope of A to B, see here. All right, looks like we're going to go down this time, and so actually let me show it like that, right? I'm going down and then over. I'm falling, so go down 2. That's my rise, and then I run. I go from -5 all the way to +9. That is 14. And then same thing here. I go down 2, and it looks like I'm going from -11 to 3, which is also +14. So once again, same slope. So AB is parallel to DC. All right. We have now proven it, because since two sets of parallel lines, so AB, CD is a parallelogram. All right. That should be sides here. I think that's all.